All right, so while we're waiting for the last couple people to turn in 4.1, make sure they're up here. Just a quick reminder, this is what we did last week. We went over some polynomials and some power functions. So remember, power functions have degrees, like a power function of degree n is x to the n. So this was degree 1, that's degree 3, that's degree 2. So we've got names for these first couple, but after that we just call them general power functions. And we looked at the overall shapes of these, graphed a couple that were a little bit weird, talked about end behavior. Said like on this one right here, of those 4 terms, that first one has the most influence on the overall shape. Talked about zeros. What's another word for zero? Solution. What were some other words we used for zero? Okay, they're right here. A solution, a root, an x-intercept, and a zero. All of those are the same thing. Okay, so we use those pretty much interchangeably. We graphed a few of these, and then we talked about turning points, how many turning points it can have. So if I have a degree 7 polynomial, how many turning points can I have? Up to 6. It doesn't have to have 6, but it can have up to 6. Okay. We talked about how we could tell what the multiplicity was of a factor. We talked about if it was an odd multiplicity, it crosses. If it was an even multiplicity, it touches. And we graphed a couple of these that looked like that. And then we did a matching one as the last example there. So are there any questions on 4. Very nice. Yeah.
I have one comment.
Yes.
Most likely JTAG.
Most likely JTAG. Yes, you're right. Not only do they make noise, they get in our way at breakfast time, right?
Yes.
Yeah. Okay. Does anybody remember how we? Okay, listen up. We ruled this one out. We ruled out D really quickly. We ruled this one out because it had too many turning points. Does anybody remember how we decided which one it was here, whether it was A or B? What was it? The y-intercept. Wow, they are really having fun up there today. Okay, so we looked at the y-intercept, and we noticed that just looking at this, you can tell a couple things. You can tell it's got a degree 4 polynomial, so it's got to start up and end up. Okay, so it's got a positive in front of that. It can have 3 turning points, and it's got to have a y-intercept that's negative. Just by looking at the graph, you can tell that much about it. So that's how we narrowed it down into that one right there. Okay, so at the bottom of the second page, we're going to do this problem right here. This is very similar to the problems that you've got on your assignment. So I mentioned that we covered the basics last time. You could actually get started on the assignment. Hopefully a few of you did, at least a few problems there. They're not that bad. They take a little bit of getting used to. These are a lot of simple steps thrown together. Okay. So it says analyze the graph of the polynomial function. So when we say analyze the graph, what we mean is figure out everything you can about it. What's the overall shape? What are the intercepts? Can we label some points? You know, and get a decent graph of that. It says find the x and y intercepts of that graph. So let's take a look here. Let's see, what's the easiest intercept to find? The x or the y? The y is, because you can just look at it and you can plug it in. What is a y-intercept on this one? Okay, it's going to be 0. Okay, so the y-intercept is going to be 0. So it's going to go through 0, 0. The next thing we do is we can look at that and we can say, overall, what does this look like? What's the most dominant term here? What's the degree of this polynomial? Okay, it's degree 3. We look at that first one. And we're going to say this one looks like, or we might say it resembles, x to the third. Now, if there was a negative 2 in front of that, I'd say it looks like negative 2x to the third. Okay? If there was a positive 5 in front of it, I'd say it looks like positive 5x to the third. Okay? But the big idea here is it looks like x to the third. Okay, now let's factor this. The first thing we're going to do is we're going to take out the greatest common factor. So that leaves me with x, and then x squared plus x minus 12. And then if I can factor that a little bit more, that's going to make things a heck of a lot easier. So I've got x, and then I'm looking for 2 numbers that multiply to be negative 12 that combine to be positive 1. Okay, so we're going to use a negative 3, and we're going to use a positive 4. Now, for each one of these, we're going to list a couple things. So 0 is the x-intercept, the solution, the root, the 0, whatever you want to call it. What is it from here? 3. From here? Negative 4. Then we're going to write down the multiplicity for each one of these. What's the multiplicity for each one? Ooh, careful. I heard a couple zeros. Zeros isn't quite right. Remember, there's a 1 as an exponent understood to be over each one of those. So the multiplicity is 1 for every one of those. So does it touch or cross at each one? Crosses. If it's odd, it crosses. So it crosses, crosses, crosses. We good there? Okay. All right. So let's mark off 0. Let's mark positive 3. Let's mark negative 4. Okay. And then remember, this looks like x to the third. So does it start down here and go up, or does it start up here and go down? Okay, starts down and goes up. So we're going to come up here, and when we hit negative 4, okay, now everybody watch, please. Okay, some people, nearly everybody gets this right. They put the negative 4 in the right place, they put the 0 in the right place, they put the 3 in the right place. Okay, and then when they go to graph it, they look at this. Now all of these are the same. They all do the same thing. But when you're looking for what happens at negative 4, find the negative 4, look down here, it says it crosses. So we're going to cross through negative 4. Let's find the next one. The next one is 0, because sometimes they're not in the right order. Okay, we put these in numeric order. We put these in ascending order, but they're not always in that order when we look at our list here. So let's find 0. What does it do there? It crosses. So we need to turn around here, we need to go through 0, and we need to cross. Now we need to touch 3 or go through 3. Let's find 3. We actually cross through there, and it looks like this. We put arrows on the end. We could label the points. Okay, so this is negative 4, comma 0. This is 0, 0, and this is 3, comma 0. And that's a pretty darn good graph. We've said it looks like that. We've shown whether it touches or crosses there. Any questions? How many turning points does this one have? It has 2. Now, if it's degree 3, it can have up to 2. Does that match with what we already know? It does. Okay, so let's see if we answered all the questions. It says, find the end behavior. In other words, find the power function that the graph resembles. Did we already answer that? We did. It resembles x to the third. I like saying it looks like. That just makes a little bit more sense to me. Okay? Determine the maximum number of turning points. Okay? It was 2. It happens to turn out to be 2. Put all the information to obtain a graph. Well, gosh, we graphed the entire thing and then went back and answered the last couple questions. Okay? It's literally that easy on several of these. Okay, are there any questions there? Does that make sense? Easy enough? Okay, I pointed out what the assignment was last time. So here's the assignment. So hopefully you take a look at you've taken a look at those. Okay. Then the next one says form a polynomial of degree 5 that has zeros 2, negative 2, and 3 of multiplicity 2 and 0. So I've got 1, 2, 3, 4 zeros. Now if it's degree 5, how many zeros should it have? Should have 5. Should have 5. How many have I listed here? Only 4. Okay? Except for, what's this guy right here? It says it's multiplicity 2. Okay? So if 2 is a 0 or a root or a solution or an x-intercept or whatever you want to call it, what factor would that come from? What would it be? It would be x minus 2. What would the exponent be on top of that if it's multiplicity 1? Well, we wouldn't put 1, but it would be assumed to be 1, right? Okay. What is the what's the factor that comes from the 0 of negative 2? X plus 2. See how easy this is? Okay. Next one would be x minus 3. How do you indicate that its multiplicity is 2? You put a 2 over it. Okay, and the last one, how do you indicate that we've got a x-intercept or a 0 or a solution or a root of 0? What factor does that correspond to? Just plain old x. Okay? Now, everybody listening? Okay, I'm fine with this. Okay? If you look in this section and you look at the instructions or you look in the back, here's what they actually want you to do. What they'd want you to do is they'd want you to multiply the two of these together. So that would be x squared minus 4. Okay, the first one's multiply to be x squared minus 4. Is everybody okay with that? Okay, this next one multiplies to be x squared minus 6x plus 9. Is everybody okay with that? Perfect trinomial square. And then we'd multiply that by x. So I would take x squared minus 4 and I'd multiply it by x cubed minus 6x plus 9x. I'd multiply all of these out and I'd collect like terms and that would be the answer. Yeah. Oh, yes, yeah, thanks. Thanks, yep. Okay. So I'd multiply all those together. I'd have a degree 5 polynomial. You can tell it's degree 5 because if I take x squared, this first one, and multiply it by x cubed, what's the very first term in our polynomial? X to the 5th. Okay, does that make sense? Okay. If you multiply one of those out, if you have more than one, just get the factors. That's really what I'm concerned with. Okay, and that you understand this process. Do one of them that way, and then the rest you can just write down what the factors are. Okay, are there any questions? Okay, let's do a couple more examples. So if you'll flip the page over. We've got some that are really easy. It says determine which are polynomials. Now, in order to be a polynomial, it has to be made up of power functions. Okay, so like 2 is technically a power function because it's 2 times x to the 0. Okay, we have to have 0 or whole numbers that are bigger than 0 as exponents. So you couldn't do something like this. Is that a power function? No, not really. Not for the ones we're going to use. Okay, that wouldn't make a polynomial. Okay, what about 2x to the 3rd? That's okay. What about 2x to the negative 1? Not okay. Okay, because what that would do is that would put the x in the denominator, and that's not okay. So not okay here, not okay here, not okay here. Stuff like this is okay, or that again would just be a plain old 2. So is that a polynomial? Yep. What's its degree? Okay. Okay. Yes, and it's degree 3. Polynomial?
Yes.
Yes. What degree? What is it, Charles? It's degree 4. Polynomial here?
No.
Okay, why not? Well, what's not okay is having an x in the denominator, but is 1/2 okay for a coefficient, as we call it? Yeah, this is just a line. A line's a polynomial. Okay, so the answer there is yes. What's the degree? Degree 1. Okay, next one. Is this one okay? Okay, here's where we run into a problem. It's okay to have a 2 in the denominator. It's not okay to have an x in the denominator. So that one is nope, that's not a polynomial. Next one here, this g of x. Nope. Problem here is not the x squared and not the 2. The problem is the x to the 3/2. Okay, we don't have rational exponents when we're dealing with a polynomial. Okay, how about this guy right here? Nope. It's got a square root. Technically, it would be x to the 1/2. That's what it would be. Okay. This guy right here? Nope. That's what we call a rational function. And how about this one? It's written a little bit weird, but is that a polynomial? That one is a yes. Okay, because if we multiplied everything out, let's see, what would the leading term be? Don't say anything out loud. What would the leading term be on this polynomial once we multiplied everything out? There's an x squared. If I multiplied this out, this would be an x squared. And then I've got a 2 in front, so this would be 2x to the 4th. Okay, so that's what it would look like. That would be the dominant term. That would be the overall shape. So how many turning points could that graph have? It could have 3. Okay, up to 3. All right. Okay, a few problems. Again, these are very similar to the ones on your assignment. It says in problems 23 through 26, use transformations of the graph x to the fourth or x to the fifth. So we know what this one looks like. Steeper and flatter in the middle than a parabola, and x to the fifth starts down here, really steep, flattens out for a second, and then goes up like that. Okay? Those are the power functions that we're looking at. And it says use transformation. So use that stuff that you know about how we move parabolas around to move these around. So I'm going to take the x to the fifth graph and do what with it? Okay, we're changing the x, so it's going to change it in the x direction. It's going to be a horizontal shift. How far? 2. Which direction? Right. So this is going to be right 2. So we're going to take the graph, and all we have to do is go 1, 2, and then it's going to go something like this. Okay. Now we could label a couple points. This would be the point 2, 0. What would these points right here be? These other two guys? 3, 1, and 1, negative 1. Because remember, if you go over 1, you'd normally go up 1 to the fifth. Well, 1 to the fifth is just 1. Okay? Same thing if we go to the left, we just go down. Any questions? Okay, would you graph this next one? Just a quick little sketch. Label a couple important points on the graph. This should look really familiar. It's just a slightly different shape. What does the 2 do? That's going to be left 2. What does the 3 do? Down 3. So our graph is going to look something like this. 1, 2, down 1, 2, 3. So we're right here. Okay, that's kind of the center of the graph, if you will. And it looks like x to the fourth. So it's not a parabola, but it does start up here and end up here. So we'd graph something that looks about like this. Remember, it's going to be a little flatter and then steep like that. Put arrows on the ends. We should be able to label at least one point on either side, because if we call this the vertex right here, if that's the vertex, we'd go over 1 and up 1 to the fourth. Well, that's just 1, whether we go to the right or the left. So if this is -2, -3, that point right there would be -1, -2, and this one would be -3, -2. Okay? And that's a decent enough graph. Okay? Any questions? Is there a, let's see, so we've got this much left on this paper. Is there a backside to your, sweet. Didn't I tell you you'd have some time to work on this in class today? Okay, so good. All right, so here are the instructions. Okay, I want you to watch, because there are parts of this that I don't want you to do, and I don't want you to do some extra work. So on 45 through 56, for each polynomial function, list each real zero and its multiplicity. That's easy enough. Determine whether the graph touches or crosses at each x-intercept. Easy enough. Determine the behavior of the graph near each x-intercept. Okay, we're not going to do that. Okay. In my opinion, that's a little bit silly, and it's not something that you do in 1050 either. Okay. Determine the maximum number of turning points on the graph. Determine the end behavior. In other words, find the power function that it resembles for large values of x. Okay. So let's do the first thing. List each real zero and its multiplicity. Okay. So 4 never equals 0, so we don't get a 0 from that. What about this factor right here? What's the 0? Okay, -4. What's its multiplicity? 1. Touch or cross? Cross. Okay. What's the 0? -3. Multiplicity? 3. Touch or cross? Cross. Remember, odd multiplicity, it's going to cross. Okay. All right. Nothing else there. So we've taken care of A and we've taken care of B. Determine the maximum number of turning points on the graph. Now, this polynomial isn't written out for us, so we can't just look at the leading term and say, hey, what degree is this? We've got to think about this for a second. So if I were to multiply this out, this part would be x to the third. That would be the leading term for that part of the polynomial. Everybody okay there? What would this one be? Just an x. Okay? So if I multiply those together, I get x to the fourth. Now my question for you is, does it look exactly like x to the fourth, or is there a little bit of a change on this one? Don't forget the number out in front. That number out in front is really important. Now on this one, it's a positive 4. So if the regular old x to the fourth graph looks like this, what does the 4 do to it? Okay, it stretches it, vertically stretches it, kind of makes it elongated, right? Makes the points taller. Okay, now that's not a huge deal, because all we did is went from this, everybody watching, because I look like an idiot up here, okay? Went from this to this. Not that big a deal. But what if that were a negative? Then that completely changes the shape. It goes from looking like this to being flipped vertically and then stretched, okay? So when you say what it resembles or what it looks like, don't just take the variables and say, oh, that's 3, that's another one, so that would be x to the fourth. Take that number. Nice. Should we have you take it and see who it is? Good. Okay? This is what it looks like. That coefficient there is a big deal, especially when it's negative. Okay? So that's what it looks like. And then the maximum number of turning points. Up to, careful, up to 3. Up to 3. Okay, now, on some of them, they have you identify all of this information and graph it, and then on the others, they just have you identify the information. So here's A and B. So this stuff right here is for A and B. This actually is the answer to what? That's actually the answer for E, and this is the answer to D. Okay? Everybody got that? Okay. Any questions? Okay, I don't want you to write this. Okay, I just want you to watch. If we were supposed to graph that, here's what we'd do. Draw a little xy plane. It needs to cross at -4. It needs to cross at -3. It looks like x to the fourth, 4x to the fourth, so it's going to start up here. When it gets to -4, I find the -4 and then look at what it says it's supposed to do. It's supposed to cross. And then when it gets to -3, we got to turn around and it's got to cross there also. Now, that's not a very interesting graph, is it? How many turning points does it have? It looks like it only has 1. Okay. I suppose it could have wiggled around in here. That's tough behavior to find, especially on this right here. You wouldn't be responsible to find that here. Just graph and label things. Okay. So that's what we'd do if you were asked to graph and label it. Okay, let's take a look at the next one. Take a good, well, let's see. Let's work backwards on this one. Okay, what's the 0? 2. What's its multiplicity? 3. Touch or cross? Cross. Take a good look at that one. Yeah. You can't have a 0 in there. Okay? In fact, if we tried to solve this, this is what we'd get. X squared plus 1 equals 0. That would give us x squared equals -1. Then we'd take a square root. And what do you get when you take the square root of a negative? You get an imaginary number. So this would be plus or minus I. Can you graph that on the x-axis? No. So there are no roots, no zeros that come from that. So we figured out what the 0 is. We figured out whether it touches its multiplicity and whether or not it touches or crosses. Okay. What power function does this look like for big values of x? What's its end behavior? So this would look like x to the third. This looks like x squared. So overall it looks like 4x to the fifth. And how many turning points can it have? Turning points up to 4. Okay? Any questions? Sure? Okay, let's take a look at this last one. It says, which polynomial might have the graph given? Okay, so this is where we kind of have to think backwards. They give us the graph and we've got to think, well, wait a minute. What could this look like if we wrote it down as a polynomial? Okay, so it crosses the x-axis at 0. It crosses, or excuse me, it touches at 1 and it crosses at 2. So let's figure out the factors that correspond to this. So if I've got 0, 1, and 2, and here it crosses, here it touches, and here it crosses. First of all, let's figure out the factor that goes along with this. How do we get it to cross at 0? What factor does that correspond to? Just plain old x. X minus 0 would just be x. What factor would this have to be? This would have to be x minus 1. And what factor would this have to be? This would have to be x minus 2. So let's take a look here. Well, it looks like they all have something like that, or something reasonably similar. Okay? But if it's going to cross, what does the exponent have to be on this? Got to be odd. If it's going to touch, even, and this one, got to be odd. Okay? So let's run through here. Are there any that we could cross off? If we know it's got to be x to an odd number. Okay, well let's see. This is b's gone. Okay, we know it can't be that. D is gone. We know it can't be that. The others are still around. So it's just b and d we can get rid of based off that. It's odd. X. Oh, okay. I was just looking at this guy to start with. Okay, now let's look at this one. X minus 1 to an even power. So this is x minus 1 to an odd power, so you can get rid of that one. Even, even, even. Okay? This has got to be x minus 2 to an odd. Well, that's an odd. That's an odd. Okay, now take a good look at this. That doesn't quite look right. What's wrong with this? Yeah, okay, we normally write x minus 2, but let's see, if you plugged in a 2, does that make that 0? 2 minus 2 is 0, and it's odd. So technically that works, okay? So we've got it narrowed down to these 3. Now we've got to think just a little bit, okay? How many turning points does this have? It's got 3. That means it's got to be at least degree 4. Let's go through and see. Well, that's 1, 2, 3, 4. That's degree 4. That's 3, 2. That's degree 6. And that's degree 4. Okay, so all of them satisfy that one. This one starts up here and ends up here. So it's got to be like x to the 4th or x to the 6th or something like that. But it's got to be positive, right? Let's check and see. Well, that one's positive. That one's positive. How about this one right here? Okay, take a good look. Hey, somebody who was in my 10-10 class. What are they trying to do here? They're trying to trick you. They're trying to mess you up. So let's write this the way we normally do. What I'd normally do is write this as negative x plus 2. And I wouldn't leave the negative there. So if I factor that out, I get x minus 2. Okay, there's that stuff, and there's the minus 2x. If I were to take this negative and drag it out front, what's a negative times a negative? Positive. So a better way to write this, the way we'd normally write this, would be this. And is that one okay? Starts up and ends up. This actually looks like 2x to the 4th. That could be it. It crosses here, it touches here, and it crosses here. So actually, whoops, let me change colors here. Any one of these could be okay. The only ones that we can rule out are A, D, and B. Okay? All right. Any questions? Okay, so you've got 20 minutes right now. Go ahead and get out 4.2. Get started on that. I will take a few quick questions on this tomorrow, but we've really been in depth on this. So what I'd like is, if you've got a question on this, get started on the assignment and ask it now in the next 20 minutes before you leave. So tomorrow when you come to class, I can maybe take 1 or 2 questions at the most and we can get started on the next section. Okay? All right, have at it.